Hello, participants. This is Sushant from Skill to Hire. So, I welcome all the participants to this day three session on blockchain and Bitcoin fundamentals. So, finally, we have come to the last day of this 3-day workshop on blockchain and Bitcoin fundamentals. So, we have to wait till 6 for the other participants to join. And meanwhile, you can keep posting your queries in the chat box. Kaushik will be answering those queries. And share this YouTube link to your friends and to your colleagues as soon as possible. So we will try starting the session exactly by 6:05. So share this with your friends and with your colleagues and tell them to join as soon as possible. So let me know in the chat box whether you can hear my voice clearly or not. Type yes if you can hear my voice clearly and type yes if you can see the screen clearly. Yes, I welcome all the participants again to this day three workshop on blockchain and Bitcoin fundamentals. Yes, I welcome all the participants. Yes. So uh, type yes in the chat box if you can hear my voice clearly and if you can see the screen clearly. I'll be waiting for your responses. Yes, good evening all. So yes, if you can hear my voice clearly, type yes in the chat box. Okay. Yes, thank you. So finally, we have come to the final day session on this blockchain and Bitcoin fundamentals workshop. So once again, I sincerely thank our branding partners for this 3-day workshop on blockchain and Bitcoin fundamentals. So these are our associate partners: School of Computers, IPS Academy, Malareddy Engineering College, Sri Manakula Vinayagar Engineering College, Jnana Bharati Institute of Technology, Nanda Engineering College. So our sincere thanks to all the branding partners and also to all the participants who are supporting me, supporting our team, supporting our mentor, and I thank you for your patience and thank you for attending sessions regularly. So yes, I request all the participants to subscribe our YouTube channel because in the near future we might be hosting many such free webinars and workshops. So definitely you have to subscribe to our YouTube channel to get notified instantly. So subscribe to our YouTube channel to access more such free webinars and workshops. Meanwhile, you can keep typing your queries in the chat box. So you can just keep typing your queries in the chat box. Good evening, all, and welcome all. Um, so I'll hand over the session to Kaushik. So you can keep posting your queries till 6:05 p.m. So Kaushik will be answering all your queries till 6:05, and even during the session, he will be answering your queries. But make sure to be in the session by 6:05 p.m. Session will start exactly at 6:05 p.m. So yes, Kaushik.
Hi, Sushant. Can you hear me?
Yes, your voice is clear.
Okay. You can share my screen.
Yes, fine. No, we will share it from 6:05 p.m. So
Okay.
now you can just engage the participants and take the queries.
Good evening, all. I'm Kaushik from Skill to Hire. So, if you have been following, I am the mentor of this 3-day workshop, right? So, if you have any doubts in day one and day two sessions, you can post your queries in the chat box, so I can answer it. So, to summarize, on day one, we discussed about blockchain technology, right? So, we have discussed about short physics, hash function, immutable ledger, distributed between network. We have discussed about different consensus algorithm like Byzantine fault tolerance. We have discussed about cryptocurrency mining. So if you have any doubts, you can on those concepts you can use them in chat. Coming to day two, we have discussed about norms range and all those stuff, right? So we have discussed about the 51% attack. So if you have any queries on those two sessions, you can post the queries in the chat box. So please share the link with your friends and colleagues. They can and also subscribe to our YouTube channel for more the live lectures and videos. So I will start the session in 2 minutes. If you have any queries, you can ask. Meanwhile, so I think there are no questions. You can feel free to ask during the lecture also. So I'm going to start the lecture in 1 minute. Okay, so let's start. So in previous session, there is a question. Why do miners not mine the transactions if there is there is a transaction fee, right? So you should. It's not mandatory, but if you didn't give any transaction fee, they don't mine your transaction. So you will definitely keep the transaction period. You are going to pay some think it is of a tax to the miner, right? So you will pay miner fee to execute your transaction. Otherwise, it will be left in the memory, as we have seen memory in the previous session, right? So all the pending transactions will be there in the memory pool. So the network gives some time to the pending transactions. If the transaction is like, I think it's 1 hour, I think, in Bitcoin. So after 1 hour, the pending transactions in the memory will be taken out of the network. So you should again do the transaction. So you don't want that, right? You want your transaction to go to execute fast, right? So you need to give some transaction to the miners. So let's start this now. So on day one, we have talked about blockchain technology. Right? On day two, we have talked about Bitcoin and other cryptocurrencies. So in today's session, uh, we are going to understand this technology in a different perspective rather than we understand the perspective of mining. In today, we will understand it in the perspective of transactions. So how cryptocurrency transactions work, how do miners pick the transactions we have seen before. So how those transactions get executed, how wallets use your transaction. We will see. So this is our agenda today. So we will see transactions at UTXO. What is that UTXO? As I have told before, transaction fee. So I will again tell about what is transaction fee. So I will tell you how wallets use our balance rate. So I will talk about signature, private key, and public keys. I will show you a demo of how private keys and public keys work, right? So we have seen Andrews Brownwood website, right? So the same website we will use to show you a demo. So we will see what is public key versus Bitcoin networks differences, right? So many of you have confusion, right? But so we will talk about that. So we will create a paper wallet. So I will tell you what is paper wallet and so how it will be done. So next we will talk about hierarchical deterministic, which are called as HD wallets. So we will see a live demo of how a HD wallet will look like. I will show you a Bitcoin Electrum wallet how it will look like. I don't do any transactions right now, but I will show you a demo of the wallet how it will. What are the transactions? So to summarize all the concepts, I will explain about Bitcoin transaction lifecycle. So while explaining it, I will cover all the concepts that we have discussed in 3 days session. So you will get a overview of how everything will be working in the Bitcoin. So while discussing about transaction lifecycle, you will get to know how things work in a clear perspective. If you are in a jumbled mind, if you didn't get all the concepts correctly, you will get them correctly in while we are discussing about transaction. So let's dive into. Let's see what is transactions and UTXO. So let's talk about how transactions work in traditional banking systems. So let's say Bob has 10,000 rupees in his bank account. So let's say it's a State Bank of India. Alice have 10 rupees. Let me open my point. Okay, Alice also have 10 rupees in her bank account. So let's say HDFC or then the bank. It doesn't matter. So what how transactions work in banking in traditional banking is if Bob sends 2,000 rupees to Alice. So if he sends 2,000 rupees to Alice, so the Bob's balance will be changed to 8,000 rupees, right? It is so quick. So 10,000 rupees. Now the Bob balance is 8,000 rupees. That 2,000 rupees will be added to the Alice balance, right? So it is 2,000. You know that already, right? It's simple, right? In traditional banking system. So in Bitcoin, it will be not that simple. Why we will see and how Bitcoin transactions happen. We will see what is the UTXO. So in traditional banking system, it is simple to transact with each other. So once it is done, it will be up to the database or record within the previous, right? So it will be so fast. So let's see about Bitcoin transactions. Let's say this is my address. I am going to use this address as my address in the whole session. So remember 0x123 is my address. So some of my friends send me Bitcoin. So this 0x456 sent me 0.7f3. Let's think about it. Just imagine, yeah. So 0x7f3. The address will be so long, not only 3 digits. So for imagination, for simple perspective of view, I am taking only 3. So this 0.7f3 send me 0.5 Bitcoin. Let's say 267. So I got some Bitcoins from my friend. So these are pegged to my address, right? So my address received those transactions, right? So what these transactions are called is UTXOs. The full form of UTXO is unspent transaction output. So what that is, you can see in the full form, right? Those are my transaction output. Some of the transactions which are unspent. So that means I can spend now, right? So UTXO is unspent transaction. Now I have total Bitcoin balance as this total, right? So these transactions live in blockchain, so no one can tamper. So now I want to buy a car for 0.5 Bitcoin. So unlike traditional banking systems, how transactions goes now, I should give 0.5 Bitcoin to the car owner, right? So under the hood, how the transaction will work, we will see. So this is the transaction. So what is my input? And what I have is these UTXOs, right? So I should take one of the UTXOs or multiple. So to cover this with 0.5, right? So the network will take 0.6 BTC, which is near, right? So I take that 0.6 BTC, which is sent from to me from 0x276. I take that UTXO. This is my input. I send to the car owner 0.5 bit. So give me a second. Yeah. So the rule in Bitcoin blockchain is there should be no unknown output. So anything that keep as an input, the whole input should go out. That means there cannot be any change left. So here 0.6 Bitcoin, right? I have in this UTXO. So 0.1 Bitcoin change should not be left in the input, right. So this whole transaction should go to the car owner. I mean, not to the car owner, should go to the output. So what the question here is, so you need to send to all of your 0.6, but you can send it to different participants, right? So you can send different participants. So what you do is you send 0.5 BTC for car owner and remaining 0.1 BTC back to yourself. So it will be again UTX yourself. So that means this 0.1 BTC is nothing but sending 0.1 Bitcoin to 0x1 again itself, right? So 0x1. So the rule is there should not be any unspent outputs. So that's why we should take this entire transaction and we should send that entire transaction. But we can send to different multiple parties. So, we send 0.5 BTC to the car owner, and the remaining there should be no change after. So the remaining 0.5 BTC we will send back to ourselves. So at first it will be tedious, but we will see some examples. Right? You will get the whole idea of. So it is so different when compared to traditional banking systems. So so what happens is this transaction is no longer my UTX because I spent it, right. So this is no longer my UTXO. So what happens is the 0.5 BTC, which I have sent to the car owner, it's simply like 0x123 sending to that car owner, right? So this will be the UTXO of the car owner. So that 0.5 BTC becomes the unspent transaction of car owner. So the car owner can spend those 0.5 Bitcoin. So it's no longer my UTXO. So I have sent back the remaining 0.1 Bitcoin to my address. So it will be again it comes to my UTXOs. So we will cut off this 0.8 BTC and we will add this 0.1 Bitcoin to our UTXOs. Now what Bitcoins I have to spend is 0.7, 0.3, 0.1 and 0.1. So I have these 4 UTXOs which are spent. So this is my balance. So what a basic overview. So let's see an example. We will see about transaction fee also in the main. So we will see about transaction fee in the example, right? So this is our example. So again, I got some bitcoins from my friends. Say 0x5, 4f6, 7f3, 10 with 0 bitcoin 1 3. So you can see 0x968 and 2 times, right? 0.4 Bitcoin and 0.3 Bitcoin. So although it is 2 different transactions from the same address, that means they should not, there should won't be there. 1 minute, guys. There won't be 2 different combined transactions. There will be as like 2 different transactions in the blockchain. So even if the same address send me different transactions, that means I don't have this combined 0.7 BTC came from these servers, right? So there are entirely complete different transactions. So there will be complete different UTXO for me, although it is sent one. So now let's say I want to buy a car for 0.9 Bitcoin and a bicycle for 0.02 Bitcoin. So what I will do is, so I need to pick some UTXOs to cover this balance. So I pick this 0.4 BTC from 0x968 and 0.3 BTC from 0x123. This is the UTXO for myself. You can see that 0x123 from 0x. I have sent it before something. Remember, I have sent it myself. And another 0.3 from 0x968. So you can calculate this one. So it is total 1 Bitcoin. 4 plus 6, right? It is total 1 Bitcoin. We need to send 0.92 Bitcoin to the owners, right? So we can send to multiple participants. So what the wallet does is it sends 0.9 BTC to the car owner, which will be the UTXO of the car. We have to send 0.02 Bitcoin to the bicycle owner, which will be the UTXO of the bicycle. So they are not for UTXOs now. So I am sending 0.06 BTC to myself. The remaining change I am sending to myself. So in banking, you will do just subtractions and additions, right? So in traditional bank system, it will be like that. But in Bitcoin transactions, these UTXOs live in the blockchain, so nothing lives in your wallet. So you will go on, you will pick the UTX valid UTXOs present to peg it to your address, and you will take those to the inputs, and you will give them to the outputs, and the remaining change you will send back to yours. So you can see that here, if you add these two, there is only 0.98 Bitcoin. So in the input we are giving 1 Bitcoin, right? So there is only 0.98 Bitcoin. Where did that 0.0 Bitcoin? So where did that miss? It is for mining fees. So for execution of my transaction, I should give some fees to the miner, right? So so that 0.02 Bitcoin went to for mining fee. So it will be the UTXO for the miner. So the miner who is mining my block can use that UTXO because now it is his UTXO. So you can spend this 0.02 Bitcoin. The miner can spend that 0.02 Bitcoin. So I hope these UTXOs will be cancelled, right? If I use them before. So this will be the remaining UTXO. I have sent 0.06 BTC to myself, right? The previous. So 0.06 to myself. So and that one and 0.105. So these are my UTXOs now. So if I want to send another transaction, again I should you should manually don't do this process. The wallet or algorithm will do it. So I am telling under the hood how the system handles these transactions. So again I will go to check my UTXOs in the blockchain, and I will add up them. I will take the nearest UTXO values for which I have to send to the car owner or bike owner, whichever I am doing. Right? So I will give them. So the remaining transaction the change I will send back myself. So there should not change. There should no remaining change. Right? So these transactions all live in blockchain, so they cannot modify this. I hope all of you got an idea of UTXO. So if you have any queries, if you want me to repeat how transactions work in Bitcoin, I can repeat again. So if you have any queries, comment in the chat box. So is asking, is Bitcoin transactions happening dark? Oh, you can do transaction from anywhere. You don't need to go to dark web, right? So from anywhere you can do Bitcoin transaction. So it is free open source. It is public network. Anyone can transact. So it's not only dark web. Normal people also trade Bitcoin and use Bitcoin in daily life. So I hope all of you got an understanding of UTXO. So at first it will be overwhelming. You don't want to digest that this kind of system by taking all the UTXOs and sending back to remaining money to myself. It is on the transaction. So at first it kind of tedious, but this is the system that the network has designed, right? So the people will run the design like this, so it will be so relevant and so efficient. So if you have any doubts in UTXOs, you can comment in chat. So to summarize, I am going to tell you again. Please listen. So if you want to send a transaction, what the wallet does is it takes your address. It goes to the blockchain. It will read whole blockchain where this address transactions are. Right? It will take the UTXOs pegged to your address. So all those UTXOs you can spend, right? So you mentioned in wallet how much money you want to spend, right? So it will add up and it will take the nearest value UTXOs which are near to your purchasing, right? So it will take that as a transaction inputs, and it will give the outputs to the it will send all the UTXOs for the bike owner or car owner, whichever you are purchasing, and it will send the remaining change to yourself, and it pays the mining fee to the miner. Right? So I hope you got an understanding of the whole scenario. Right? So if you have any doubts in UTXO, if you want me to repeat, I can do it. So let's go and check some live transactions. So I will be sharing my screen. We have seen live transactions and all those people, right? So Sushant, you can share my screen, right? You can expand my screen.
Yes, I have done it.
Again, we came to blockchain.com/explorer to the live transactions. You can see the latest blocks, right? Let's go to a block. It is block mined 2 minutes, right? So these all are the transactions in the block. You can see it. Remember, the first one will be the coin transaction, which is the minor transaction. So the miner will get 6.5 BTC as reward rate. So here he got 6.78, and the remaining is transaction fees generated from the transactions. So if you sum up the miner got 6.78 Bitcoin as reward for mining this block. So these are all remaining transactions the user the user. So you can see here. Go to it, and you can see these transactions, right? So these are the transaction inputs. So you can address first, and they collect this UTXOs. These are the inputs that we have seen before. So this is 14.4 on Bitcoin, right? So these are the outputs that he is sending that Bitcoin. So 0.0024 BTC is sent to some address, and this transaction sent 0.4 Bitcoin to another address, and the remaining 14 Bitcoin sent to his address only. You can see this. This is 17 years. Let me zoom my screen. So you can see 17A16QVMAV that address, right? So the third transaction is again 17A16. So he is sending the remaining 14 Bitcoin to himself. That is the transaction that I have talked about, right? So these are the live transactions you can see, and you can go over on blockchain.com and explorer. You go to a block and see what are the transactions there. Here is some input transactions, and these are the output transactions. So the remaining thing will go to the same address. So I want to show you how real transactions work. So that's why I can. So you got a whole idea of UTXO. So there is a question: if we transfer the entire Bitcoin from the address to others, then can we have our address code empty for many days? No, Harshini, that's not what I have said. So uh, the network will do this for you. You won't be doing anything. So if your transaction fails, I mean, if you didn't pay enough fee or memory pool rejects your transaction will be reverted, right? So this is a complete transaction. If this transaction executes means again you can spend this UTXO because there is no problem in spending your UTXO. So the network maintains that. So let me give you an example. There are 14 Bitcoin here, right? So if he want to send 0.4 Bitcoin to this address, and he don't need to wait for this transaction to complete. So he can trigger another transaction, but it will be waiting until this transaction is complete. So if this transaction completes means he will get again 14 UTC back, right? So with that 14 UTC, the next transaction will get executed. So there is, I will talk about wallet balance clearly in the next concept. So there will be no such thing like balance in this blockchain. So every transaction will be there in the blockchain. So we simply go on, we see how much UTXOs are there for our address. So that is our value. So we will see that in the next concept. So there will be no such thing like wallet balance. So we don't send entire transaction to the receiver. You are sending the remaining change to yourself. So why I am pressing that point is in rest finance there is no such system, right? So in Bitcoin transactions only there is a system. So that's why I differentiated them and I have one. So for presentation. So let's see how wallet shows our balance. So if you open a wallet, you can see balance, right? So let's see how that wallet shows balance. Previously, I have told that there is no such thing balance balance field per your address, right? So let's see how wallet shows. You will get again. You will go to UTXO. You will get a revision. So let's say these are 4 blocks. This is block number 501 to 5. There are some transactions in here. So 0x123 is my address, right? So there are some transactions in this block, like we have seen before, right? So these are the transactions with some of my friends here to me. So I bought a I bought a car with 0.5 Bitcoin. So I have sent 0.1. So what I have done is previously in the previous example, this is the previous same example that we have discussed before. So what will happen is the network takes my 0. Let me open the pointer. The network takes my 0.6 BTC to purchase the car, right? So I am paying 0.5 BTC. It is the nearest value here. Right? So it takes and it gives to the car owner, and it 0.1 Bitcoin sends again myself, right? I have taken same values that we have used in the example. So for another purchase, I am sending 1.1 Bitcoin another address. So what I have done is, what the network does is, this red mark here, right? So you can see here red mark, right? That red mark represents that is a rejected UTXO. So that's no longer my UTXO. Remember, without striking off, I kept the red mark. So that's no longer my UTXO. So what this network do is to send 1.1 Bitcoin. Here I have 1.1 Bitcoin, so I'm sending to this. So it goes to the blockchain. So the wallet goes to the blockchain. When you trigger a transaction, it searches all the blockchain. I mean, 0x123 is my address, right? So what are the UTXs present pegged with this address? So that gives us 0.1 BTC, 0.3 BTC, and 0.6. So summing up all that, I have 1.1. So that 1.1 Bitcoin, it takes and it gives to the address. So again, there are some transactions, and I have to send. This is our second example, right? We have seen 0.9 Bitcoin for a car and 0.02 Bitcoin for a bicycle. So these three transactions will be taken by network, and these two transactions and 0.02 for minor we have. So same example. Now these red marks these are no longer my UTXs. So let's see how wallet shows our balance, right? So what does wallet is? Wallet uh, when you open a wallet, you will see you have this much Bitcoin in balance, right? So there is no such thing called a balance field in the wallet for blockchain. So how does it show balance means? It goes to the blockchain, it takes your address, and it will see what are the receiving transactions in that address. So receiving transaction means that my address should be right side. So these all blue lines represent my receiving transactions. So these are not my UTXOs. I have already spent it. The transaction will be in the blockchain that I have spent, right? Everything is public in blockchain, right? Those are also transactions and they will be in the blockchain. So these are not valid UTXOs. There are some other UTXOs which I have already spent. So what it will do is it will take the only valid UTXOs. These red mark UTXOs it will not consider. It will take this valid UTXOs. Here we can see 0.06, 0.01, and 0.0. You can see total 0.26 valid UTXOs I have. So it adds up all that and it shows your balance is 0.26 Bitcoin. So the wallet shows like that. There is no such thing called balance field in blockchain or anything in wallet. So what the wallet does is it goes and search entire blockchain with my address. It sees the valid UTXOs which I can spend, and it sums up all those UTXOs and show my balance. So I hope all of you understood how wallet shows our balance, right? So how it gave you a refreshment of how UTXOs work. So how transactions happen. So I hope you got a pretty good idea, right? So if yes, please comment in the chat box. If you have any doubts, please let me know in the chat box. If you don't have any doubts, we can continue. If you have any doubts, let's wait 30 seconds. So you didn't get UTXO concept. Okay, yes, I got clear. So let's go to next concept. We will see what are private keys and what are these signatures. So we have seen how many works, how transactions work in the blockchain and those was right now, right? So that's all nice and well. So all these processes we have seen before asks a very good question. What is that is that the question is of privacy. So everything is public in network, right? So it gives a question about privacy. So clearly anyone can see my transaction, right? So anyone can come and execute a transaction. So let's say someone came and executed a transaction like my address is 0x123, right? So they executed a transaction like 0x123 sending 0x456, so 1 Bitcoin. Even though 0x123 is my address, right? So it triggered a transaction to my address. So uh, then where does this privacy comes? That is my address, right? Only I should spend the UTXO in that address, right? So until now, what we have talked about, there is no way we have until now what concepts we have seen. By combining all that, there is no way to stop the transaction. So what the concepts we have discussed before, if you sum up all that, I didn't tell anything any way to stop the transaction. So if somebody comes and execute 0x123 to 0x4 Bitcoin transaction, so the miner takes the transaction. If there are enough UTXOs pegged to that 0x123 address, so and he takes and he executes the transaction, right? So what happens then is all of a sudden someone is using my money, right? So it's not fair, right? So let's see how the network tackles this thing. So the question here is how does it do some privacy? So we will use these private keys and public keys. Uh, so let's see. So when you create a wallet provider or generator assigns you a private key. It's a random generated number. It assigns you a private key. It is so large that there will be no collisions with numbers. Like we have seen SHA-25621. So that much big number. A random generator generates your private key. So this private key is like your ATM pin. So if you tell your ATM pin or the bank password to anyone, your funds are gone. So like that only, you should not tell anyone this private key. So it should be secret. So that's why this works symbol. So you should keep this private key safer and you should not tell anyone. So that's why it's called as private key. So now what? So now what this private key does is the wallet applies some algorithm. So the network or wallet provider applies some algorithm and generates a public key, which you can tell anyone. So this public key is public. You can tell anyone, hey, send this much Bitcoin to my public key, and anyone can send Bitcoin to your public key. So the important point to note here is this public key is generated from the private key. So these two have link, right? So public is private keys. The first thing that happens is the creation of private key by a random generator. And from that private key, we apply an algorithm called elliptical curve algorithm, and we generate a public. So now let's say, actually this is a basic cryptographic concept. If you are a computer science student, you have gone through cryptographic concept, right? Symmetric key, symmetric key encryption, and asymmetric key encryption. So this is a asymmetric key cryptography. So in asymmetric key cryptography, we have two keys like public key and private key. In symmetric cryptography, we have only one key, right? So this is asymmetric cryptography that Bitcoin uses. So now let's say we have our private key and public key. Now let's say we want to send a message. In general cryptography, they tell message, right? Here the message is transactions. We want to send a transaction. What we will do is we sign our transaction with a private key. So this is our signature. So we digitally sign our transaction with private key. So we will get a signature. So what we will do is, so what the miner do is, he takes this message, signature and public key. Remember the public key is generated with the private key. So these two have link, right? So this public key can be used as verification of that signature. So the miner runs a verification function to verify that whether the whether this person only sending this transaction. So what do I mean is previously I have told an example that someone came and executed a transaction with my address, right? So that should not happen because I have my private key, right? So he doesn't have a private key, so he can't sign the transaction with the private key, right? So this public key reject this verification tells yes or no. If it is a verified transaction, so if I have sent the transactions, it gives yes. So the miner sees that yes option and he take the transaction and execute it. So if the verification function fails, so the miner will just leave the transaction. The transaction will be reverted. He cancels the transaction. So it will be reverted to initial state. So now this situation is packing, right? So I have my private key. So I am not sharing my private key to anyone. So that only I can sign my transaction. So actually, these transactions, when you are using your wallet, the wallet signs this transaction with your private key. You don't do it manually. Everything is done by the wallet. So I'm telling Nandan what will be done to verify that you are only sending the transaction, right? So he takes these three parameters. He takes the transaction, he takes the signature which I have signed with the private key, he takes that public key because it is public, right? So it came from private key. So they do have connection. So with the public key, you can verify that the signature is done in that private key. So if this public key tells yes, the signature came from my private key, then it will be an S. So on the minor execute. So otherwise, it will be no means the transaction will be executed and everything will go on in the previous state. Give me 1 second. Okay. Okay. Let's see a small demo in Andrew's Bombard website, uh, which we have seen in our first lecture. We have seen lot of things in this website, right? So let's go to thanks to Andrew's Bombard for making such a good tools, right? Let me share my screen. Okay, Sushant, you can see my screen, right?
Yes, Kaushik, we can see it. Yes.
Okay. So here are some private key and public keys. So it is a randomly generated private key. Right? First, the private key will be generated randomly. So I press this random function. I am getting this much large number. Right? So this is globing. We don't know how much it is. So let's see what is its box. So it is 77 digits length, right? So I just opened a JavaScript console to see what is the length of the string. It is 77 bits, right? So there will be no collisions. There will be so many combinations, right? You can take that 77 factorial combinations. There will be no collisions in private key. So this is an example. This is not a real private key. You can't take this private key and put in your wallet. Nothing like that. It is for demonstration purpose. So you can see while I'm generating these random numbers, I got a private key and I got a public key. Now let's go go to signatures. So here is a message. Here is a private key which I have generated before. So what I should do in the previous picture you have seen, right? So I should sign a transaction, I mean message with my private key. So let's do it. So let's say Kaushik sent and let's say this is a message. This is for demonstration purpose. There will be addresses here. So let's sign by using this private key. So let's sign. We got this signature. This is the message signature we have got. So now we successfully signed out our message or transaction. So now let's verify without public. So go to this verify section. We have our public key generated with the same private key, right? Here 998. So this is the same public key 046 which is generated from the. So now we will take the message and we will take the public key and we will take the signature. So we have taken in all three parameters, right? So now let's verify. So you can see there is some green message going up. So it is verified, right? So let's say I am paying this public key. So now this is not the public key. I have changed the one letter. So now this is not the public key generated from our private key, which we have signed that. So now let's verify. So it is giving red, right? So that means no. So this is not the public key. This is not the private key pegged to this public key. So the sender is not sending this transaction. This is the public key of someone else. I am trying to send transaction with someone else. Means that it failed. So only I can send my transaction. So this private key and public key make include that only you can send. You can spend your transaction. You got it clear, right? So there is another second to see. So yeah, it's same thing, but here are some transactions. You can go and check on this website and try. You can play free time. So this website I will paste in. You may. Sushant, I am sending this link to you. So you can put that in chat box.
Yeah, yes, Kaushik,
So now,
I'll do it. You can
now,
continue.
now let's go to our presentation. So we have seen private keys and public keys demo, right? You understand how different keys work. So if you have any doubts, you can ask them in the comments. So if you have any doubts in private key or public key, you can ask. Okay, let's go to another concept: public key versus Bitcoiners. So people, so many people confuse about address and public key. Some even think they both are same, right? So no, they are two different entities. Public key is public key and Bitcoin address is address. So we will see what this difference between public key and address, right? So we have seen this whole process before, right? We have seen first private key will be generated and the public key will be generated. You can sign this message using the private key, and miner uses this verification function to ensure that the transaction is sent from not from the other. Right? So we have seen all these methods. So now this address is generated by using hash function on this public key. So why this address? We have public key which is visible to everyone, right? So why address now? Why there is a new field called address? Meanwhile, if you have public key. So address is usually used to ask people to send you money. So if you are requesting money, you will share your address. This if I am asking my friend money means, so I will tell this is my Bitcoin address. You can send money to this address, right? So we use address like that. So the interesting thing here is people can send Bitcoin straight to the public key also. So why not sending? Why not you can share your public key, right? It's already public key. So why this different field called address means? So let's see why we are having this different field called address. So the reason why here is we actually try to keep avoiding sharing the public key. So it is already public. Why safe? So this process is entirely not protected. So by sharing address, right, that means you are not sharing your public key, right? So it is already public. Anyone can see public key. So, but they don't whether it is your public key or not. But those public keys are in the blockchain, right? So it is visible. So you remember that when you execute a transaction, you should give your public key to the miner, right? So the miner will verify your transaction. So keep the point in mind. So that means we definitely will have to expose the public key when we send bitcoins to someone else. So without public key, the miner cannot verify the transaction. So you will have to expose your public key when you send your money. But if we can avoid to expose public key when receiving money, we should do that. So the question is why we are not exposing public key when we are receiving transactions. So the reason is public key is generated by using private key. Right? Also, we can't reverse engineer the private key by seeing the public. At this point, I didn't mention. So you cannot reverse engineer this public key, this private key by seeing this public key. So it is like one-way function. We use elliptical curve function to generate this public key. So we don't get into technical about how this elliptical curve. So let's imagine if at some point, if this elliptical curve is reversed engineered in future, and if someone does that, then if you are giving public key for every transaction, then very quickly somebody can get your private key, right? So if in future something was happen at elliptical curve function, elliptical curve mathematical function is reverse engineered to get the private key, right? So if in future something happens like if you send public key to every transaction by sending a transaction and receiving a transaction in the future, so you're exposing your public key a lot. So the hacker or attacker can get your private key easily. So we avoid some extra layer of security. The Bitcoin network came the concept of Samtas. So it is not entirely a quick protection of our public key. Our public key is exposed when we are sending transactions. So it is very good to keep a extra security layer, right? So if you are avoiding exposing your public key while receiving your transactions, so it may take some time to for the attacker or hacker to regenerate your private key. So it is highly impossible to reverse engineer that private key. But if some point in the future, if somebody reverse engineer that elliptical pyramids, so it gives some time for the Bitcoin network community to do something to fork the network or to do an update for that process, right? So if you expose your public key very often, it is so easy for them to regenerate that private key. So it is not an uh, entirely correct protective method, but it gives a extra layer of protection for us. So simply, you can use anything to send your bitcoins, right? You can share your public key. So it is quite often you can share your. It is. I think you now you got a whole different perspective of public and right? So they both are public. They both can be used to receive transaction. Public key is used in sending transaction to verify that transaction, right? So the public key and address are different entities. Address will be generated by applying chart and double hash algorithm uh, for the public key. Let's see this process. So first we get private key, right? Uh, the, the wallet applies elliptic curve multiplication algorithm to get the public key. So the public key is used to generate the Bitcoin address, right? So the public key will be applied sent to this algorithm. It uses double hashing. First it hashes with SHA-256 and plus it. Again the hash is hashed with RAPED 160 algorithm. We don't see technical here. So just I am saying what functions they use. So they do double hashing and we will get public key hash. So this is pub key hash. So by doing base 58 check encoding process for this public key hash, we get the Bitcoin. So this is a quick overview of how these four will be generated. So first the private key will be generated random, remaining all will come with that private key. So if you want to know about in depth how exactly these private keys and these functions work, so you can see this video by Matt Thomas. You can go and search Matt Thomas in YouTube. So he explains all the Bitcoin concepts so much clearly. If you have that time. So I'm giving a basic overview so that you can get the whole system idea. So if you directly go into the complex concepts, you can't understand it. So if you get a whole flavor of how things work in the network, then you can understand the concepts. You can go into in-depth concepts. So you can go and search Matt Thomas in the YouTube. You can go and search Bitcoin address and public key. You can go and search. I think there is no need to share this link. Okay. I think you got an idea of what these private keys, public keys, and signature and users, right? So if you have any doubt, please comment. So I think there are no doubts. Okay, so now let's go to our next concept. Okay, we should see a paper wallet. Right? I have told you, I will be showing you how to prepare a paper one. Paper wallet is nothing. A Bitcoin wallet, it gives you a public key and private key, but it is famous in the starting of Bitcoin, right? So that there are different types of wallets that came into place. We will talk about those on. So just I want to introduce to this paper wallet so that you get a basic understanding of how a wallet looks like. So paper wallet, why it is called paper wallet means it can be printed in the paper and you can safely keep the paper, right? So this website generates some randomness by making here in this text box. You can see, right? So let's say this is my password. Something, right? I'm getting some random generators. While I move mouse, you can see there are so many green dots, right? So this website generates so much randomness, right? So by moving, this detects my event. This is detecting my event, and it generates whole 100% randomness. This is a big string random. So it gives a Bitcoin address and private key funds. This is the private key. I will be not using this wallet. It is only for demonstration. I don't have any funds in this wallet. Just I have created.
Kaushik,
So, yes,
you
Sushant.
are just sharing the presentation, Kaushik.
Okay, sorry. Okay, I will share my screen. I will give you the demo again. No problem.
Yes, now we are sharing it.
So this is the paper wallet we have. Paper wallet generator. So while I will moving the mouse, you can see whole random number generating. So you can type something, right? Use some randomness. So you move on the mouse, it will generate a. So this is this random number is to generate or plate. So if the 100% is completed, so you can get this private key and Bitcoin address. So this is my private key, and this is the address. We have just created a paper. So you can see, right? You can print this, and you can take the piece of paper and you can put it in your a bank or something in your. You can keep that safely in your house. So these paper wallets are famous in starting when Bitcoin came into place. So now they are not using paper wallets. There are too many wallets that came advanced from them. So I just want to give you a quick overview of how these paper wallets work. So you can see there are so many bulk wallet, brain wallet, vanity wallet, split wallet. You can go and play around with this. It is bitatlas.org. You can go to that website and you can try and playing around with that. If you want to use a paper wallet, so this is your secret key. Uh, if, uh, if you generated the randomness piece, you will get a secret key and Bitcoin address. So you can share your Bitcoin address to anyone and tell them to send some address, some Bitcoin to this address. So if you lost this private key, there is nothing that can be recovered. So if you once you lost that private key, the funds in that address cannot be taken out. So it is important to keep in mind. So if you lost private key, the funds will be So in previous days, those papers are non-read, so they can't keep that paper safely so much time, right? So something happens, some members lost those paper and like the thing. So, but I want to show a demo what paper. So you can go ahead and play with this website. So let's go to our presentation. Okay, let's see another wallet type called hierarchical deterministic. Give me a second, yes. Give me 1 second, please. Yeah, okay. So these are the next generation wallets that came paper wallets, right? So uh, these are called HD. We will see exactly what. So here we have our whole setup, right? So we got our whole setup that we have discussed in exact diagram to you, but I will not explain this again, right? So I have explained detailed in the previous chapter. So in previous concept, we have discussed about all these private key and public key, what they do to verify. So the question comes again here is privacy. So let me give you an example. So we know that different blockchains in general are meant to be anonymous or exactly not exactly anonymous, pseudonymous. You can think of it. So as long as nobody knows uh, who this private key is attached to, so they don't know who you are. Simply in network you have an address, so anybody knows that this address is pegged to you, right? So they are completely anonymous, right? So because mm, if someday someone finds out who is behind that private key, then they will know exactly everything about you and what you have been acting and what transactions you are doing. So these technologies are meant to be anonymous or pseudonymous. Then the network should use a ability, right? So if if someone knows that this private key or this public key is without, they can monitor your transactions, right? So, but if you think about it this way, uh, to send you money, you have to give your address, and every time you send money, you are attaching your probability with the transaction, right? So somebody can just go through the blockchain and pick up every time you would address your public key pops up in the blockchain. So they can start observing things, they won't know who exactly this address, but they will see some patterns, right? So like this public key is used to send money to these specific four addresses very often, right? So like that, they can see some different patterns. So maybe at one point they figured that you paid to an address in a pizza shop. Let's say that guy also went to that pizza shop and he know that transact. So I made this transaction in this pizza shop, right? So this address belongs to this pizza shop, and same he also. So you have also done a transaction to that address. Means he knows that you are coming to this pizza shop, right? So uh, you will be exposed like that, right? So he takes you and he visits the shop, right? So how much you are? So it's actually quite a big concern, right? So someone can examine the pattern and uh, they can find you, right? So this gives some extra question on again privacy. So if a network promises that things like they're going to privacy, then it should provide, right? So let's see how network tackles this kind of. So we can see people can simply create multiple private keys and generate public keys with each one and addresses, right? And you can use different addresses and public keys in different places to cover your tracks. So they cannot recognize any pattern. So instead of using one address and one private, you can use different addresses and different private keys, right? So to cover your track, to be safe, you can do different transactions with different private keys and keys. So they don't know if your one key is exposed on, but you can do. other transactions with other keys, right? So um, it gives some extra security. So, but becomes tedious to maintain this many private keys safe, right? So it will be tedious to keep these many private keys safely. So keeping one key safely means is so much headache currently. So we should think of process of where we should put the private key, who we should recover. So keeping track of all these private keys safely is a bit tedious. So what what the so after some point of time, Bitcoin introduced an improvement called BAT32. BAT stands for Bitcoin Improvement Proposal, and they proposed these HD wallets. So let's see what these HD wallets. So with a HD wallet, we get a master private key. So from this master private key, a private key is generated from the master key. So you know this process, right? From this private key, you get a individual public and you get this address, right? So we apply elliptical curve algorithm. Here we apply double hashing with star 56 and RIP 63, and we do some base 58 things. Right? So you know this process. So this hierarchical deterministic wallet gives you this master private key. So you should keep your master private key and this private key also safe. So you should lock. You should not expect this private key or master private key. Then your funds will. So we will see what the use of master private key. So if you want to create another pair of keys, simply this master key generates you other pair of private key and public key pair. So it simply add one to this before private key. So it adds one to it, and we get another private key, whole new another private key, right? So it is random generator number, right? So you should enter the number, you get a whole random. Now you can generate key pairs with the graph. So like that way, you can create so many key pairs you want. But these all are pegged to this master private key. If you expose this master private key, so he can get all these addresses simply. So it must be the wallet gives this private key. So he can add accounts and adding by to this private mask, this private key, he can get all the public key and private keys. So if this private key is exposed means nobody can stop your account. So this master private key gives you a accessibility so that these all private keys are equal to this master private key. Right? You will see exactly how this is tolerant, where this is used. Right? Give me a second. Give me a second. Okay. So there will be a master. So if an organization is, let's say, if an organization is going to use Bitcoin or cryptocurrency for their services, so let's say in organization there will be so many of us, right? What they could do is they can have like a main director. There will be main director in the organization. So they can have this master file. So they can keep this master key. So using this master key, they can monitor every transaction with this children private key. So this private and public key pair belongs to one set of members in the organization. So the beauty of this master private key, this hierarchical deterministic policies. So this organization can pay this and some of the groups, let's say if it is a software development group, there will be some groups like testing phase, tester group and developer group, right? Like so many different branches in that organization. He can give these private key pairs to one organization or an organization. So he can monitor all the transactions with this master private key. But these can only monitor their transaction only. Right? They only have one key. They don't have other key. So if they get master private key, they can generate all this. But by exposing one private key, you don't get these other. So that is the thing to keep in mind. So the main head can monitor all that. So this also gives an extra key to master public key. So what is BAP32 gives is the master public key. So where do we use this master public key? So this master public key gives you all public keys that we have generated. It doesn't give private key because you can't predict the private key mixing public key, right? Unless you break that electrical function, you summon the mixing stuff. But it's a hard one. You can't do that. You can see about electrical current TCDS here uh, in the internet if you want to know the map behind it. So this master public key is to create so many different public keys. Uh, means where we get to this master public key. Um, so let's say in that organization there are some auditors. They don't do transactions, right? Auditors only verify the transaction. So they don't need private keys, right? So uh, they don't need this private keys. So the head of the organization can do is he can give this master public key and he can tell the auditors, you generate all the public keys and you verify all the transactions that are going in our public branches, like all the financial branch, production branches. The head of the organization can give this master public key to the auditor and he can verify this. So he is eliminating or exposing these private keys to the auditor. Right? So he can give this master public key and he can tell them you generate different public keys. It's master public key. So this master public key is generated through this master private. So these two have linked. So that's why it is getting these public key access. So uh, yeah, he can get rid of exposing that private key from the audience, right? So it is a good thing for him. Right? So for auditors or something for verification sections, you have master public key also. So I hope all of you got an understanding of how you can see this hierarchy, right? So that's what they are called hierarchy. So these are called healthy ones. So in paper wallet, you have seen only one private key and one public key. It gave us it was not a private key. That's it. So by using these wallets, you can do this many things. So you can maintain this one master private key and you can do any. So there is another improvement for that, after that. So uh, you don't need to remember this master private key. So the wallet providers or some other wallet generators, what they will do is they give you some 12 word keyword. So they will give some random 12 words as your seed phrase. So what this seed phrase is, we will take a look at a entire SD wallet how it looks like. I will install it and I will give you a demo. So uh, instead of remembering this master private key, so if you go to a wallet, so wallet asks that if you have already a wallet you want to import or you want to create a new one. Let's say I want a new wallet, so I press the create new wallet. Then it gives something this like this 12 words. You can see, right? This is the seed phrase, which collapse, practice, feed, shame, open, disappear, check, road, again, ice, least. There are some random words. It is giving 12 of those. So these are my private keys. You can think that you should never expose your seed phrase. So from this seed phrase, it generates the master private key. From that master private key, it can generate so many pairs of addresses. So instead of remembering that master private key, it gives this all seed phrase words, right? So you can remember them. So you can just store these. They tell that store securely these 12 words when creating. Right? So uh, you got an idea, right? So this is called the seed phrase. We go and download a SD wallet called Electrum. You can go to electrum.org and downloads. I will paste the link in the description. So I have already downloaded the wallet. So I don't need to download again, but I will share my screen 1 second. Give me 1 second. So this is my exe file, .exe file, which I have downloaded from the website. You can go to that website and you can go to downloads and you can install these binaries for Linux users, for Windows users, for Android users also. There are some binaries. So I installed Windows 1. So let's go on install this one. So I have downloaded the exe file. I simply double click it so it will ask me to saying so the wallet is installed. You can say the wallet is installed. Sushant, can you see that installing process? Sushant? So, okay. I think see this is so I'm closing this. So now the wallet is let's go to the wallet. Here is my so here is my I am opening it. You can see this name. So this is so small. I think you can see this font, right? So I can't zoom this font. Give me a second. Sushant, can you see this? Can you see this from wallet? Right? So sorry, I have a doubt. You didn't see it. Is master public key only for the last public key? No, no. I just drawn that arrow. So Faisal, it's not for only last public key. It's all the four public keys series. So we have seen that all the public keys that are generated from those all different private keys, right? So the master public key is used to get all the public keys, not only those that last one which I have given an arrow hit. Simply I have done that. So not only last one, you can get all those keys. So you can see, you can see this. I not able to change this one. So this is a asking which wallet you want. I am simply setting it. It is asking me a password. So let's take a password. I want to create a new wallet. I am creating a new wallet. Go take it on. Sorry, thing happened. It is wrong. Okay. Sorry that for that before. Uh, let's press create new wallet. So I want a new wallet. Right? So it is asking me what kind of wallet do you want to create. So it has so many options called standard wallet, wallet with two-factor authentication, multi-signature wallet, which I have not discussed in this session. So multi-signature wallet is uh, you will use three different private keys like that to sign a transaction. So previously we have used one private key to sign a transaction, right? You can use three private keys to sign a transaction. So it is a multi-signature one. You use multiple private keys to sign a transaction. If one private key is exposed also, there will be no such thing of loss of funds because they need to get another two private keys. So that is the concept of multi-sig. So now let's say I'm going to continue with standard wallet. So I want a new seed phrase, right? So I'm clicking to create new seed phrase. So seed phrase is nothing but we have seen before, right? So I'm pressing next. This is C type. Just go with segwit. I'm not explaining about what is the segwit segregated things and everything. What's you can search in it's telling me that yeah. So this is my. It is so small. I think you cannot see right. I am not able to change this. Let me look. I don't know whether it's working or not. Yeah, I think now it is somewhat clear. So this is my seed place that the wallet generated for me. So what I should do is just I need to back up the seeds. So let me write it. It will ask for verification whether I have picked up. All dollars. So I won't be using this wallet guys since I am exposing my seed face. So this is only for demonstration. You can create a wallet. I am not storing any funds in this. So don't try to uh, paste this seed place and waste your time. So I have successfully written my seed place. So I'm pressing next. So it is asking to type the seed. So here you don't have a mistake. That is the reason. That's why. So I'm typing my seed place. Cash. So I have typed this. I'm pressing this. So it is asking me to create a password. Password. Setting up this one. I'm pressing it. So this is my electron monitor. So I have created my electron. So you can see this folder, right? So this is a send where you can paste your uh, receiver address and you can send your. Currently, I don't have any money. Yeah? Recently, I don't have. So you can go to receive and you can do a request, right? So this is the Bitcoin address. This is your Bitcoin address. You can see the QR code. So you can simply share your QR code and ask someone to send some Bitcoin. So this is a hierarchically deterministic wallet. So we got a seed phrase. It generated a private key pair for us. So you can go and see here so many addresses. You can filter the addresses. I think there are so many. Uh, you can take the customers. So yeah, this is my addresses. So these are all receiving addresses. Means these are all my addresses. So I told you before, right? So one public key where when one master private key gives you so many private keys, and those from those private keys we get so many public keys. From those public keys we get these many addresses. So these all are my addresses. So as I have requested only addresses list, so it came addresses list. So these are all my addresses. I can share any of these address to get funds to my. So I have something like this. You can see so many, I think, private keys. Thanks. So these all are my private keys. So you can see all my private keys here. They are source code. So all your private keys are secret. It's showing that one. So these all are my private keys. So you can see my private keys, right? So these are all my addresses. You can these are my people up to key hash which I have to keep. So these all are. You can go around and see how your wallet looks like. So you can ask your seed phrase by entering your password. That is a confusion, right? If you remember your password, you can again see your seed phrase and note it. So this is my seed phrase. So what are the? I have used this so many days, years. So the UI has changed, so I don't know what's there. Official website. So one thing to note is the sign and verify. Yeah, you can see this. This is a message. We can write something, and we can make matters. You can do something. You can paste this address, and you can put your signature, and you can sign it. So it will ask your password to sign the message. So you are getting the signature. So I think I have wrote something garbage here, and it's signed with my private key. So I have given this address, right? So the private key taken to this address generated this signature. So you can sign this by private key. You can verify this signature is signature verified. So if something I have changed, say I have changed wrong signature, says. So you can do so many things with these wallets. So you can go around and play with them. You can actually go to test network and get some test Bitcoin if you are interested. But it is mainnet. So I hope you all got how hierarchical deterministic wallets work. So it uses a bunch of master private key. First, I actually use a seed phrase. You can keep the seed phrase. That's all. You should keep that seed phrase safe. That's it. You should not remember anything. If your laptop crashed or something happened also, if you have that seed phrase, you got to recover this all your private keys and publics using the seed phrase. So that's a main system hierarchical. So you need to only your seed phrase safe. If your laptop crashes or something happens in hardware on the crash. But if you have written those seed phrase somewhere safely in your house, in your computer, so you can regenerate all those private keys and public keys simply by going and while I'm installing it said I told that for creating new wallet, so you can tell that I have already a wallet, so it asks your seed. So if you enter that seed, it will generate all those private keys and public keys that previously you lost. Yeah. So it is like a backup system which is given which these hierarchical deterministic wallets are. So I think all of you got an understanding of how they so let me close this. Let me take my process again. Okay. Let me share my context. So I think all of you got an all overview of how HT wallets work, right? So we have seen this element. So my main thing to remember is if you want to store it, if you have anything Bitcoin, you go to Electrum official site. So if you go to some other fake site, then they manipulate you and they tell you share your seed place, and if you have get them, it will be lost. So if you go to official website, you should, uh, check that if it is official or not. So I hope you all basic understanding of how UTXOs red shows balance. You have seen in paper wallet, which is only you have seen positive wallet. I have told you how it generates in the same place and how that master private gives it in right? So I hope you all got an understanding of whole point. So okay, now let's go to our last one concept called Bitcoin transaction risk. Until now, what we have discussed in these 3 day sessions, I will give a quick overview of seeing some diagrams. So this is a basic human diagram of transaction life. So let's say this is the sender. He has some word like I have found it. You can go to alpha mode. Something gets up alpha mode. He want to send to it triggers a transaction. The algorithm verifies that we have seen that verification function, right? So it takes that signature of the key and the transaction and it verifies whether this sender is only sending this transaction or not. So after verification is done, the transaction goes to memory pool. We have seen that memory pool before, right? So this is a pending transaction that is waiting in the memory. What these miners will do, we have already discussed how miners pick transaction, right? So if you give high gas fee, they will pick those transactions first. So these miners do is they collect transactions from the memory. We have talked about detail this concept in previous session, and they apply this. They participate in this consensus. They do this cryptographic puzzle, right? They compete. They compete with each other by doing that cryptographic puzzle, right? By solving that by using so much computation power, as we have seen in mining sessions in day 2 session. So they find this valid hash. When the one who took the valid hash will add the transaction to the book and add the block to the blockchain. So this transaction is executed, and the UTXO first UTXO changes it. So now the receiver gets that UTXO which he can spend. He got 1 Bitcoin. The wallet shows he got you have balance of 1 Bitcoin. Checking this UTXO figure to the receiver is. I think all of you got a basic idea of how this whole transaction life cycle is, right? What are the participants life cycle, everything, right? So this is another picture I have taken from the internet. So it is not clarity, but it can show again the same process. So here this guy is Rob. He opened his Bitcoin wallet. He scans or copies LoRa service. He places the amount and the fee to the miner and sends the transaction. This code is a user. Nothing user can do, right? So if you are end user, you will do simply this much process. What this wallet does is the wallet signs the transaction using Rob's private key. As we have seen, the transaction will be signed with Rob's private key. Right? The transaction is propagated and verified by nodes in the network. So whether they verify that they execute the verification function, whether you sign this transaction with your private key only by seeing your signature and public key and transaction. Right. So what happens after that? If it is verified a transaction, the miner sees the transaction and they go into mining process. So this is all mining type. So in mining, new bitcoins are created. The miner, you can see the miner who solves the propagates the new block to the network, which creates new bit. We have seen that block reward generates new bit. So this process of mining is completed. The node, the miner or broadcast this block to the blockchain. So the nodes verify the result and propagate the block. So we have seen the concept that if a miner is a node, so how we have seen that in business protocols in the one session, how the network nodes is they all verify before adding the block. So they do series of checks and they add the block to the blockchain. So now Laras is the first confirmation. So new confirmations appear with each trade. So it is good to do some block verifications so that your block will not be added into the orphan blocks which we have seen. Right? So if there are competing chains, there is another chain, longer chain, orphan blocks. Right? So to avoid that orphan block, to avoid the orphan block, you wait for 12 or 13 block informations. So the chain will be sufficient long enough to so that your transaction will not end up in a orphan. So you will wait. It is best way to wait for 13 confirmations. So again, the Laura gets that UTXO in the blockchain, so she can spend the UTXO. I think all of you got a whole understanding of what we have done in these 3 day sessions by seeing this transaction life cycle. So if you have any notes, please comment in the chat. So we have discussed the whole concepts and we have discussed all these concepts. So that's it for this session. And if you have any doubt uh, uh, in any, not only Bitcoin blockchain or any other nodes, you can ask in the comment box. Um, you can ask any query. So please comment in the chat box.
Yes, Kaushik, can you hear me now?
Yes, Sushant, you can.
Yes, yes, fine. So I'll share my that feedback link in a while. So that's all for this 3-day workshop actually. So participants, if you have any queries right regarding these 3-day workshop or regarding anything related to blockchain, Bitcoin, anything as such, you can just post those in the chat box. If you even have any queries with skill to hire also, you can just post those in the chat box. But try to ask queries related to blockchain and Bitcoin and cryptocurrencies in the chat box. So it can be anything. Actually, these 30 minutes, we left this 30 minutes for the Q&A session itself. So try to interact in the chat box and ask your queries. Even once this live session is done, right, you can freely post your queries in the comment section. So our teammates will be answering your queries. Like Kaushik will be answering your all your queries. Even if you post your queries in the comment section, once this live session is done. So meanwhile, you can just ask queries now in the live chat box. Within 5 to 10 minutes, I'll just post this feedback link in the chat box. And thank you for your good responses. Like we got some good responses on day 1 and day 2. So we hope the same for day 3. Yes, fine. And a simple notice that I want to make here. I'll be posting the link and I'll be accepting the responses only for 5 minutes. So what happened earlier is yesterday the strength was around 40 live people were watching, only 40 people were watching live, but around 165 responses we got. That was quite, I got surprised actually. So I'll be just posting the link and then I'll be accepting the responses. We'll be accepting the responses only for few minutes, like 5 to 10 minutes. After that, I'll be starting. I'll be stopping accepting the responses. So make sure to fill the Google form immediately. That is the feedback form immediately. So based on the responses itself, your certificates will be distributed. So yes, and one thing I want to say you, like if you have any yes, fine. So yes, you subscribe to our YouTube channel so that in the near future we are going to host some more free workshops also on different domains. It can be web development, it can be IoT, it can be what we can say data science, AI, machine learning. So we are hosting many such free workshops. So do subscribe our YouTube channel and be subscribed. Don't unsubscribe once this session is done because as I have told you to get notifications whenever we host free sessions, right? Just be subscribed and click on that bell icon. Yes, Kaushik, you can go with the queries.
Okay. Okay, Krishna. So Manibharti is asking what means signatures. Let me tell you why we use signatures. So it's a digital signature. It is something you can use to show that you know that private key connected to the public key. So don't reveal that private key, right? So, but you want to tell that um, I have this private key. It is like zero knowledge proof, right? So you don't want to expose your private key, but want to tell that I have this private key. I am doing this transaction. So what you do is you sign that message with that private key. If you ask him about technicalities, that means I think you do some math with that message with that private key. So you give some. There is a function called signature, and you are giving that signature your private key and that message, whatever message you are signing. So it generates. It do some math. The function do some math functions and it do some iterations, and it gives you a signature with that private key. So what you do is you take this signature and you show to the miners like that, right? So they can verify that signature with the public key. So this public key and private keys are pegged with each other, right? As I have told. So they get they can verify that this message is signed with the private key. So they can verify it from that public key and taking the signature. And there will be a verification function called verify sig in Bitcoin. So you can use those two inputs like public key and signature. This. So that will verify. So because our public key is getting from private key, right? So those two have linked. So you can use to tell that this signature is belongs to my private key. Came from the parent private key. This public key tells that this signature is came from my private key. So you don't want to expose your private key, right? If you expose your private key, your funds are gone, right? That's why you do this signature process. So if you want to know about signatures, you can search in like what are digital signatures and how documents are. Right? There are so many research papers you can read about. Okay. Are there any? If you have any queries, you can post them.
So yes,
I
Satish.
have.
So here, Kaushik, give me a minute. So here, the point is we cannot share these presentations to your mails or anything as such. If you want to go through the presentation, right, then you can just go through this YouTube video and you can just go through the slides that Kaushik will be explaining in that video. But we cannot share this PPT to your registered mails or anything. So I hope you understand. Yes, and any queries related to the subject, Kaushik will be answering. And if you have any queries related to Skill to Her platform or anything as such, I'll be answering. When will we get the certificates? Yes, you will get your certificates in a week. So we'll be sending all the certificates. Like if you got registered to this particular workshop from any of our associate partners, right? They will send the certificates to you. If you got registered from Skill to Hire platform, like you were if say you were an earlier participant of any of these workshops and you got to know about these workshops by our marketing mails or anything as such, then in that case you have to in that case only Skill to Hire will be sending you the certificate. So I think I got your I explained you clearly. So if you got registered from associate partners invitations, you'll get the certificates from them, or else you'll get the certificate from us. And once again, I sincerely thank our branding partners. So let me just display our branding partners. For sincere thanks to all our branding partners. See, meanwhile, you can just keep posting your queries. Kaushik will be answering. No worries.
Yeah, yeah. So the reason why we have worked about Bitcoin blockchain is I have told you before, right? So you will get the whole understanding of this technology. So if you now you go into Ethereum or some other platform and you want to try to understand, it will be so easy. You know all this concept, you know how signatures work. So if they use differently, also you can compare with this and you can get the whole notion. That's why I
So,
have talked about
Kaushik,
Bitcoin
is my
blockchain.
screen visible now?
Yeah. Ah, yes, Susan.
Yes, okay, fine. So, sincere thanks to all the branding partners. And let me just display our branding partners. So, these are our branding partners or associate partners for this 3-day workshop on blockchain and Bitcoin fundamentals. So, our associate partners are School of Computers, IPS Academy. Thank you. Malareddy Engineering College, thank you. Sri Manakula Vinayagar Engineering College, thank you. Vijnana Bharati Institute of Technology, and also Nanda Engineering College. Thank you. We thank all the organizing committee of these particular colleges who have collaborated with us for conducting many such free workshops. So Yes. And thanks to all our participants also. They were being very patient, and also they were asking many queries in the chat box. We are happy about that. And as I have told you, I have posted this feedback form link in the chat box, and I'll be stopping the responses in 5 minutes. So make sure to fill that feedback form. Once the time is 7:50, right, I'll just stop accepting the responses. So make sure to fill the feedback form before 7:50 and keep asking your queries. Yes, sir. I'll share all the responses. I'll share the responses to the associate partners. No problem with that. Yes, fine. Yes, Kaushik, you can go.
So I got a question: why do people mainly go with such alternative currencies? So that's a good question. So, honestly, Manoj, that's a good question. It's not about currencies. So that's what I'm trying to talk about. I'm telling you why I have chosen different options. You will get the whole mix of technologies. It's not about currency, it's the technology behind it. The blockchain technology is not only for cryptocurrencies. It has so many advantages in other fields. So you can take health sector, right? So health data is so private, right? So you need to trust others when you're studying. So by using this blockchain technology, you can share your health data without losing that data, right? So no one can look at those data when it is blockchain. So there are some private blockchains, consortium-based blockchains like Hyperledger also, which take this concept to another level, make those consortium networks, and they can be used by corporate companies. So you can take, uh, let's say you are an artist and you want to pay money, you want to get paid for your. So if you do a art exhibition, no one will come because you won't have publicity, right? So let's say you are in music fair, and you want this, okay, you go to some Ghana or some podcast. So the Ghana app will benefit, right? So what's in you are the you are the main key, right? You are doing that music, right? So you can eliminate those middlemen, and you can use this technology instead of those middlemen. So why this technology is so powerful is you can eliminate so many middlemen. So you don't need to trust anyone. This is a trustless environment. You don't need to trust anyone. You should just trust the technology. So it's not about currencies. That's all. So why do people mainly go for such alternatives? If they don't want to uh, use the currency, right? You can see now US is printing so much money, right? During this crisis, there is stimulus of 2 trillion happening. So why, if you want something, the dollar value go less, or something, there will be inflation, right? So if you want to, why are you taking gold if you have money? That is another question. So why are you keeping gold if you have, right? Because gold is precious. So like that, some currencies like Bitcoin are also precious. They have only 21 million uh, total Bitcoins in the world, right? So this technology is so big, so no one can hack it. And you have seen in this 3 days session, right? You have so many features. um, how this network is hard to break and why it is so relevant. So you want to store it, or you want to keep some Bitcoin, right? So in future, if there's something, any crisis came and all your money went, and take example of Venezuela. In Venezuela, they all depend upon oil price. So they dig oil and they sell. For some time, it is okay. The country is okay. And when all oil price suddenly goes down, the whole economy of Venezuela went down. So if you want then at that time, if you want to buy a tea, you should take whole bag of money and buy a tea in Venezuela. So they throw the currency outside the doors, right? They throw it in wash basins. There is no. What they did is uh, what the government did is printing money. So when petrol rate is so high, they are giving money to the government employees and all the shops. You can see basic gift shops also maintained by the government. So when they relied upon only petrol. So what happened is when petrol price drops 40% once, and the whole economy went down. So what the president did is, so we can print money and we can use that money to the government employees and all those. So what happened? The inflation rate became so high. So this is some economics. So if not, so if the inflation is so high, the whole economic collapse, the whole country is in some serious issues, right? What they did is, so if you go to Venezuela, each shop will accept cryptocurrency. So the country is saved. I tell the country is saved by cryptocurrency. So you can see that why you want to choose alternative currencies. This is an example, but this is not entirely about currencies. It's about the technology. So if you have any queries, please email me. So we will end the session at exactly 8 o'clock. So if you have any queries on these 3 day sessions, or if you have any general queries about blockchain, you can post that in the. So subscribe to our YouTube channel. So if we conduct any workshops on blockchain or other technologies, so, uh, if we conduct any free workshops, you will get notified.
Yes. So I think Kaushik, there are no queries left.
Yeah, yes.
Yes. So thank you all. Thank you for your participation for this 3 day workshop.
There is a question. Is it just like Google Pay and Paytm, but for all? Yes, yes. You can think it of it is Google Pay and Paytm have all these benefits. Uh, but this is a public network. They can see your addresses. Nobody don't know who is behind that address unless you tell this is my address, right? So there are no. One thing is cryptocurrencies are all also used to transfer between different countries. If you transfer in PayPal, you will so much cut-off rates from one country to another. Someone send from money from Australia to you. Even one of my friends sent me, and there is so much transaction PayPal. So what we have done is we switched it to we have so it's a best use case. So there are so many applications coming like to do such kind of thing. Like doing, so you can do international transactions. Okay, Sushant. I think there are no things we can do.
Yes. So yes. So I think we have come to this end of this 3 day workshop on blockchain and Bitcoin fundamentals. So once again, a sincere thanks to all the associate partners and also all the participants that have participated actively in this 3 day workshop. And having said this, I again request you to subscribe to our YouTube channel for more such free workshops and also free webinars that we are going to host in the near future. And also, at any point of time you can just go through the recordings, like go through these videos which will be available in our YouTube channel. So not only this, we also have some pre-recorded videos, like we have some 3-day workshop. We had some 3-day workshop on deep learning. You can also access those 3-day workshop. And also we had earlier we had some workshop on introduction to IoT and embedded systems. Even that too, you can just go through those recordings if you are interested in that particular domain. So in this manner, we are trying our best to give our best. And you can just support us by subscribing to our YouTube channel. And yes, thank you. I thank all the participants once again. And thank you, Kaushik, for explaining them in such a good manner. So, yes, so I will be ending this session now. Yes, thank you all.